I discussed that we have the two type of traffic. One is the HTTP that is going to work on the port 80, but this is going to be always in plain text, right? And if I talk about the HTTPS, this is going to work on 443, but this is always going to be encrypted traffic. So right now, whatever testing we have done for the URL filtering, like basically for the vulnerability, virus, that file blocking, these all are basically based on the HTTP. Means every content which are not encrypted, then it is going to be your HTTP traffic. But if it is going to be encrypted, then the firewall is going to be helpless. So now let's suppose this is my user, this is my firewall, and this is the internet. There is a connectivity. This want to talk to internet. If it is in the plain text, all content ID can be applicable on this traffic, and this firewall can be take action, allow or block, whatever you want to do that. But if this is going to use the encrypted traffic, this firewall is going to be helpless to, even some traffic is going to be in terms of the virus, and it's showing via the, like it's traveling via the Palo Alto firewall, but it's an encrypted firewall is never going to understand it's a virus or not. So firewall is going to be allowed download virus traffic, upload virus traffic without any problem. So basically that is going to be encrypted problem when the traffic is going to be 443. So that's not good for us. If my firewall is there and my firewall is basically going to be process traffic from source to destinations, and that traffic is encrypted, and there is a malware, there is a virus, there is a bad URL, there is a spying activity, you should block that traffic as well. But it's not going to block. To solve this problem, we have the term that is known as the SSL decryption. So the topic we are going to talk about, that is the SSL decryptions. This SSL decryption is going to give the flexibility where any encrypted traffic is going to be there, that is also going to be. Let me show the demo first. Okay, then we'll test it. Let's suppose this is the user and try to download some virus file. Let me apply some antivirus policy first. And then I'll show you what is the problem I'm going to talk about. So this is trust to untrust policy. I'll go here and apply the antivirus policy. Similarly, we create it and I'll go commit it. This is going to be commit. So it is going to be there. I will go on this particular PC, client user PC. I will go here, open the google.com. So its commit has been done almost. So I'll go here and try to download a test virus file. Test HTTP virus file. This is the plain text virus file I'm trying to download. Okay. And probably I will go and find, yeah, this is the virus file. So we tested in the earlier case also. If any HTTP virus file is going to download, it is not going to be download. So let me open it and say this file is never going to be open. This file never ever is going to be open. But if I try to download the HTTPS file in different tab, let me try to open new window. See, this file is getting open. But HTTP is getting blocked. Why it's getting blocked? Because we have the antivirus profile apply and that's blocking. But HTTPS is not blocking. Again, it's a malware. Both are the malware, but it's not blocking. So how I can block it? What is the way around? So we have to enable the SSL decryptions. So in SSL decryptions, we have the concept. You can see this is the policy which happened. Even we are sending any encrypted traffic and you want to block, then your firewall is going to act as a middleman. Middleman means it is going to act as a, let me open one of the documents so I can show you in nice way. Hold on, guys. So I will go here. I will go give me 1 second. I can open ebooks. I can show you. You can see here is my SSL decryption. You can see here. So basically, if you read it, what is decryptions? So decryption is the Palo Alto network firewalls can decrypt and inspect the traffic to provide the visibility into threads and the control protocols, certificate verification, failure handling. Decryption can enforce the policy on encrypted traffic so that firewall handle the encrypted traffic according to your configured security settings. Decrypt policy to prevent the malicious encrypted content from the entering your network and sensitive content from leaving your network considered as a encrypted traffic. Means anything from your network is going to be encrypted and want to like go in or out, that decryption is going to help on that. And it's going to make sure only the right traffic going to be processed. No virus, no malware, no vulnerability, no bad URL should be processed. So how basically this can be possible? How decryption is going to happen? Because most of the time, if you go for the L3 and L4 interview, they are going to ask that entire process, how decryption is going to happen. So in this case, your firewall is going to act as a man in the middle, man in the middle. And it's known as the MIMT, man in the middle, which is proxy. What is proxy? Anyone know that? What is proxy? Any idea?
Proxy is the one that
Pretending to be someone else.
that sends the request on behalf of the client or server.
Yeah, you guys are very close. So proxy is actually you're going to be work on behalf of someone, pretending you are someone else. Even in the college, we have done the proxy attendance for our colleagues, right? Sometime. But your colleague is not available, but you on behalf of that, you said, yes, ma'am, I'm available, and yes, sir, I'm available, like that. So what happened? Whenever client want to talk this server will think I'm going to reply to the client. That's true. But when the Palo is going to act as a proxy, then situation is going to be different. If this is the HTTP connections, normal, there is no decryptions, then definitely the client server is going to talk together. Palo is going to act as a transparent mode where it is going to do all kind of the checks for the session traffic and everything. But in proxy mode, what happened? Whenever you want to talk, the Palo Alto is going to intercept your entire traffic. Sorry. Whenever you want to talk, it is going to intercept your all traffic. And on behalf of you, it is going to talk to your server. This is the architecture. Means when you talk to the server, Palo Alto say, hey, stop it, stop it, stop here. and he will take all your responsibility and he will initiate start connection from here. He is going to reply again. He will say, no, stop it. He will again, on behalf of you, means server, it is going to start doing the communication. This is the how architecture is going to look like. Means client to server, firewall is totally going to act as a man in the middle. Is it clear till here, everyone? Is it clear?
Yes, sir.
Yes.
Okay. Julie, what about you, man? You can understand what is the proxy architecture?
Yeah, it's good. Thank you.
All right. So now let's understand what is going to happen, how this proxy is going to be like designed, and how this all process is going to happen. So generally what happen whenever you do any communication from the client to server, you guys know when you open a facebook.com, let's suppose this is the facebook.com. In between you and Facebook, what is that? That is the internet. Every data, even you uploading any photograph, any images, nobody's know within the internet what data you're sending, but it going to update on the Facebook. Whenever you open a Facebook page, every data coming to you, even all kind of the Instagram, Facebook detail, that's coming to you, but nobody is known in the man in the middle, what data, what photo it is sending and receiving by you and the Facebook. How it's possible? How it's possible? Only you and server know about that, your communication. Anyone know about that? How it's possible? How nobody never know about that any communications?
Encryption.
Because encrypted traffic
And
that is happening
what
between
protocol encrypted that?
HTTPS.
HTTPS. Yeah, that's very correct. HTTPS now. But how this client will come to know when the data is coming from Facebook, how this will come to know I can open it? Why not in hackers in between, they open this particular traffic? And similarly, if data is sending here, how server is going to open that particular traffic?
So client will have the root certificate of the server with which it is encrypted.
Root certificate of server. That's very nice. Okay, so how this client, so every server, let me show you how where certificate is going to say. If your PC doesn't have the certificate, you never going to be short.mgr. Sorry, short.mgr.msc. So every client machines, there have the public certificates, which generally server use that. And this is going to be stored in here. If this certificate is not there, you're never going to encrypt, decrypt any kind of data. You cannot see in your human language. This is how certificate is going to be there. So server also have certificate, client also have certificate. So based on the symmetric and public private key, they can encrypt, decrypt the data, but man in the middle, they don't have those certificate, unique certificate, where the credential is going to be, when SSL handshake is going to be happen, every browser, let's suppose I'm going to use the facebook.com, they are going to on the HTTPS. In the SSL handshake, they include the SNI certificate random. So those all are going to match from the client and server side. Then only it is going to possible. So if I go and show you, if you're the SSL handshake process, I don't know where it is. Yeah. SSL handshake process, client and server is going to do. Three-way handshake is going to be happen, and client hello it is going to be initiated. Then it is going to be include your SSL protocol version, SSL session ID, list of cipher suit. That's an encryption method. Out of 16 cipher suit, that server is going to select one and it's going to their own certificate to the client. Then they generate the master secret key, and this master secret key is going to be available both server and client side to just encrypt and decrypt the data. That is known as symmetric key session. This is the SSL handshake process. So whenever the communication is going to happen client to server, they use this after three-way handshake happen. They use the certification, that is the master certificate, to just encrypt, decrypt data. So these all is basically going to allow the communication from the client to server. So what happened? The client is going to send the hello. This is going to be intercepted by your server, means your firewall, which is going to act as an intermediate root CA. And what is the root CA? Basically, you can think about this is the main branch. This is the franchisee, means main showroom. It is a franchisee showroom, but same property. So this is going to generate the certificate and it's going to install in the client. I will tell how it is going to happen. But the traffic is going to intercept by your firewall. Firewall is going to initiate the SSL connection on behalf of client to server. Server send the certificate. It will keep that certificate and it will sign their own certificate sent to the client. Client verify, and then the connection is going to be established. So from client to the firewall, this is going to be encrypted. From firewall to the server, it is going to be encrypted. But when the traffic is going into in a firewall, it's going to be plain text. So even traffic is going to be HTTPS. Firewall is going to be know how to open because they have the key and it will verify whether this traffic has the malware, this traffic having any kind of the vulnerability, this traffic have any kind of the what I can say advanced threat preventions, any kind of the bad URL, and it can block. And if everything is fine, they will just allow your connection. Similarly, if you're downloading any file coming from the server, it's going to identify as a bad file based on the decryptions. It is going to block. It's the right file. It is going to be allowed. So this is a back and forth how your all entire communication is going to happen. And based on that entire communication, you're going to be allowed to make the legitimate connections. Make sense, guys?
Sir, one confusion here. The certificate will be exchanged between client and server. So, here firewall rule is just decrypt the traffic to just inspect the traffic, or just add on there like CA certificate link.
See, firewall is going to be act as an intermediate root CA certificate. It is going to do all work. It is going to issue the certificate, encrypt, decrypt, and the certificate is going to install in every client machine. The certificate also going to be, there is two methods certificate issuing. You can use the firewall self-signed certificate or third-party root certificate. If third party, that need to be imported and same certificate need to post on the client. If self-signed, that also need to be in the firewall self-signed certificate, and this need to be included in the all client machine. When I'll do the lab, you'll understand, Manas, how it is going to happen. Okay?
Okay.
Tomorrow we'll do the lab, not today, but I will explain how it is going to happen entirely, so you guys will understand in better way. Okay, so tomorrow I will just recap this again, so you guys will understand how certification is going to happen, how it is going to install, and then we'll move in the next step. Will it fine?
Okay.
Pankaj, I have a question related to this one, but anyways, tomorrow you're
Yeah,
going to
ask
go in
tomorrow,
deep.
no problem. Tomorrow we can continue. You guys take have a quick look and just come with the more questions. I will try to clarify on that.
Okay, sure. I mean, do you want me to ask now, or we can do
Let's
it
connect
later?
tomorrow. No problem. Tomorrow we'll discuss because we'll have the fresh mind, so we'll have the fresh discussion tomorrow.
Oh yeah, sure. Thank you.
Thank you, everyone. Bye bye. See you tomorrow. Bye.
Bye.
Thank you, guys.
Thank you. Bye.